We've developed Q-SPARC, a natural language chatbot that helps researchers explore Spark's high-level connectivity data through intuitive conversation-style queries. SPARC is an NHI Common Fund program which aims to map how electrical signals control organ function, supporting treatments for conditions like hypertension and heart failure. To do this, SPARC has gathered extensive data from over 60 research groups covering thousands of subjects, species, and anatomical structures. A central resource is SCKAN, the SPARC connectivity knowledge base, which captures how parts of the nervous system are connected. An earlier tool, the SCKAN natural language interface, lets users query this data using natural language and ChatGPT. Q-SPARC builds on this foundation with improved performance, interactivity, and visualization, making it easier for researchers to ask questions, explore connections, and view results with anatomical context. The problem: while the original NLI is useful, it does have a few limitations that affect the user's experience. It requires users to write precise domain-specific queries, which can be difficult for non-experts. It's a single-turn tool, so it doesn't remember your previous questions, and there's no real conversational memory. The response time is also heavily dependent on OpenAI's latency, and it accounts for 95% of the current wait time. And currently, it can't integrate with Flatmap, which limits anatomical visualization. Finally, the interface doesn't support chat history, which can make interactions feel a bit disjoint. So overall, it's a powerful tool, but it's not particularly approachable or interactive, and that can create friction for researchers trying to explore the data. Our solution is Q-SPARC, short for Question Spark. It's a conversational chatbot that supports multi-turn dialogue, meaning users can follow up questions and build upon previous answers. We focus on a few key improvements: faster access, whether running locally or in the cloud, a modular architecture aligned with FAIR data principles, open format support so it's easy to use and extend, and most importantly, Flatmap integration so users can see anatomical visualizations alongside their query results. This makes Q-SPARC more usable, more interactive, and better suited for a range of research tasks. We've also developed a short tutorial walkthrough on how Q-SPARC works. First, we show how to deploy the Q-SPARC language model and run a basic query. Then we connect it to the SCKAN dataset so it can provide expert-level responses with relevant metadata. Through a simple web interface, users can ask questions and get both structured and unstructured outputs. We have a tutorial that shows you how to interact with this web-based UI. And finally, we show how the system integrates with Flatmap to produce anatomical visualizations from the results. Each part of the tutorial is designed to be clear, practical, and easy to follow. In terms of impact, Q-SPARC improves how researchers interact with SCKAN data, making it more findable through smart search, metadata tagging, and semantic ranking. Accessible with intuitive interface and support for local or cloud-based use. Interoperable thanks to the open data format and API integrated with Flatmap, and reusable with documents and tutorials to help other teams adopt and extend it. By making the data more approachable, we've helped to increase its scientific value and broaden its reach. Finally, we'd like to thank the SPARC program and the mentors from SPARC Codeathon who supported us throughout this project. That's Q-SPARC. Thanks for listening.